Hello, we're going to look at the step question from assignment 8 of the STEP support programme. So this question doesn't have a lot of words in it and there aren't lots of different parts. It's got one request, which is to find the equation of circles which pass through the points where these two ellipses meet. Now, you don't actually need to know anything about the equation of the ellipse because they've given you it there. All we need to do is we need to work out where these two curves meet. So we've got two equations of curves, plus 2y squared equals 18. And we have another one, which is 9x minus 1 squared plus 16y squared equals 25. So these are ellipses. We don't need to know that. We can just work out the points of intersection by solving the simultaneous equations like we would do normally. So probably the easiest thing to do is to take this equation. So if I call these 1 and 2, if we take equation 1 and multiply it by 8, and if we do that, we're going to get 8 lots of x plus 2 squared plus 16y squared is equal to 8 lots of 18. Well, 8 lots of 20 would be 160. So take away 2 lots of 8 would give me 144. Alternatively, 8 times 10 is 80, 8 times 8 is 64. That gives me 144. Okay, I'm fairly happy with that now. Okay, so we want to try and eliminate something. Probably the easiest thing to do is to subtract and get rid of these y's. I'm going to choose to do 2 minus 3. This is going to give me a negative on this side, but it will mean that I don't have a negative outside this bracket, which has a negative inside it. I'm just trying to stop myself making more sign mistakes than I might do otherwise. But you can subtract them the other way around. Okay, 25 minus 144 is negative 119, I think. So if I add 25 to this, yeah, I agree with that. Okay, so expanding out the brackets, lots of opportunities to go wrong here. It's meant to be 4. Equals minus 119. So we have 9x squared minus 18x. Another nice thing about doing it, doing 2 subtract 3, is it means I'm going to end up with 1x squared. Minus 8x squared minus 8 times 4 is 32. And 8 times 4 is still 32. Equals minus 119. Okay, simplifying this bit. 9x squared minus x squared. 9x squared minus 8x squared is x squared. Minus 18x minus 32x is minus 50x. And then we're going to get 9 plus 119, which is, I'm going to do this in 2 stages, 1 to 8 minus 32. So we have x squared minus 50x plus 96 equals 0. Okay, you can use the quadratic formula if you want to, but this one actually factorizes. We're looking for 2 numbers that multiply to give me 96 and add to give me negative 50. These turn out to be minus 2 and minus 48. So we have x equals 2 or x equals 48. Okay, so we now know the x coordinates of where these 2 curves meet. Now it will be a good idea to find the y coordinates, and I am going to choose to substitute these into 1. So if we take x equals 2 and put it into equation 1, we get 4 squared plus 2y squared equals 18. So 2y squared is equal to 18 minus 4 squared, which is 2. So y squared equals 1 So y is plus or minus 1. Okay, we now need to consider the other equation. So it might be that these ellipses meet in 4 places, or it might be that they meet in 3 places if there's a repeated point of intersection. But let's just check our other value of x, which is 48, before I delete it. Okay, so let's substitute x equals 48 into 1. This will give me 50 squared plus 2y squared equals 18. This gives me 2y squared is something which is negative, and we're looking at points of intersection in the normal plane. We want to keep things real. So this is no real values of y. So we have 2 points of intersection, x equals 2, y equals plus or minus 1. So I'm just going to clear all of those. So they meet at 2 plus or minus 1. Okay, so what this means is if we have a couple of ellipses, which look perhaps something like this and this, then they're meeting here and here. And now we need to try and work out the equation of the circle that goes through these points. So at this point, we can actually now just completely ignore the ellipses. It's now a case of just trying to find the equation of the circle. So let's get rid of my ellipses, and I'll draw a couple of axes. And we've got the points 2, 1, and 2, minus 1. So these are both points on the curve. Okay. A fact about circles, which you may or might not remember, is that if you have a chord that goes across the circle, I'll draw a couple on. If you consider the line connecting the midpoint of the chord to the center of the circle, it's always at right angles to the chord. So if you take the midpoint of the chord, connect it to the center of the circle, you get a right angle. So the center of the circle has to lie on the perpendicular bisector of the chord. So I'll just write that down. Center of circle lies on perpendicular bisector of chord. And we've got here a chord because both of these points lie on the circle. So the line joining them is going to be a chord. That means that the center of the circle has to lie on the perpendicular bisector of this line, and the perpendicular bisector just happens to be the x-axis. So the center of the circle lies on the perpendicular bisector of the chord. Therefore, center looks like A0. So the center will have to lie somewhere. And I'm taking a guess that this A is going to be the same A as I get in my equation, but that would seem like a fairly good guess, but it may be that I have to change my variables at the end. So the center lies somewhere. So obviously it could be here, A could be 2, and then we'll get a circle like that. A could be over here, and then we'll get a circle, oops, which is supposed to go through there. So there's a few different options. Okay, so we now think we know what the equation of the circle is going to look like. Just create some more space. I'll just leave that picture there for a second. So the circle equation is probably going to look something like, let's just change the color back again. Oh, I'm still on rubber. So the circle equation is going to be something like x minus a squared plus y squared is equal to r squared. Okay. So this is looking vaguely good because we've got an x and a minus 2ax. That will come from expanding this, and we've got a y squared. This bit is slightly trickier. So let's start by expanding this. We get x squared minus 2ax plus a squared plus y squared is equal to r squared. So we get x squared minus 2ax plus y squared is equal to r squared minus a squared. Okay, so we need to find this just in terms of a. So if we consider our centre to be at a0, and we consider the distance between these 2 points, we know this lies on the circle. I know for this red circle it missed, and we know this is the centre. So if I draw this out a bit bigger, we have a0 here and 2, 1 here, and this is r. This is supposed to be a right angled triangle, even though it's got a bit bent. This distance here is equal to 1. This distance here is equal to a minus 2. So this distance here. So this gives us a relationship for r. We know that r squared is equal to 1 plus a minus 2 squared. So that's 1 plus a squared minus 4a plus 4. So that's 5 plus a squared minus 4a. So if we substitute that into here, x squared minus 2ax plus y squared is equal to 5 plus a squared minus 4a minus a squared. Our a squareds disappear. So this equation here is the same as the equation here. So we can say as required, and we're done. Right, just to show you a little bit of what's actually going on here, I have drawn these on Desmos. I'll just try and find it. That would help if I was actually on mouse rather than annotate. Okay, so these are the two ellipses that we found that we were given at the start of the question. And you can see here that they meet at 2, 1 and 2, minus 1. This here is the equation of the circle that the step question was asking us to find. And you can see that these three circles intersect at 2, 1 and 2, minus 1. Sorry, not three circles, 2 ellipses and 1 circle. We can also put in the point A0, and that is the centre of our circle. And then I've got a slider, so you can see that as A changes, all 3 ellipses meet at these 2 points. The centre of the circle stays on the x-axis, but the circle can get bigger and smaller and still pass through these 2 points. Okay, if you want some more step questions on ellipses, you can go to the STEP database and you can search for ellipse. And you'll find a few more questions on ellipses, some of which are harder than others. This is the question that we've just done, but have a look at a couple of them. Okay, thank you very much.